Alright, this is part 2 of the Unit 4 review for the test on linear functions, including the coordinate plane, graphs, tables, and equations. So, given the equation 6x plus 3y equals 12, identify the x-intercept and the y-intercept. Just so you know, the x-intercept will always be on the x-axis. So the 0 goes in for y. That's why I can solve the equation 6x equals 12. I simply divide both sides by 6. The 6 cancels out 6 over 6 to leave us with x. And 12 divided by 6 equals 2. When I'm looking for the y-intercept, I'm focusing just on the 3y equals 12. Because the x goes to 0. 3 divided by 3 cancels out to leave me with just y, and 12 divided by 3 leaves me with 4. So the y-intercept lies on the y-axis. When I'm going to write the equation of the solid line, I need two things, slope and y-intercept. Fortunately, we've already found the y-intercept by solving that one-step equation, so 4 can go on the line after the plus sign, because it's positive 4. To find the slope, I simply go and count my rise over run. Since this is a negative slope with a falling line, I count down 4 and right 2. So my slope is negative 4 over 2, which simplifies to negative 2, and negative 2 goes in front of the x. The next question asks about what is the equation of the dashed line, which is perpendicular to the solid line. Well, I need 2 points on that dashed line. The x-intercept is at negative 6, 0 on the x-axis. And the y-intercept, which is hard to see, is at 0, positive 3. And happens to be on the y-axis. Now that I've identified my x-intercept and y-intercept, I can start to piece together the equation of a line for that dashed line. Again, I need two pieces of information, the slope and the y-intercept. So I'm going to write y equals blank x plus blank, filling in the blanks as best I can. I'm using the light pink to draw the rise and the run. So I'm going up 1, 2, 3, and to the right 1, 2, 3, 4, 5, 6. So if you look carefully, I should be going from the orange point to the red point. I know it's really hard to see. So up 3, or rise of 3, and run 6. So the slope is 3 over 6. Because it was a rising line, it's positive 3. But I can simplify further. So 3 over 6 can be divided by 3 in the numerator and denominator, leaving me with 1 over 2, or 1/2. So y will equal 1/2 x. 1/2 being the slope, plus the y-intercept is at positive 3, so I'm going to fill in positive 3. Notice they said perpendicular to the solid line. Perpendicular again means opposite reciprocal. So the original equation for the solid line was a negative 2. We treat it as negative 2 over 1, as we did here on the far right. Opposite of a negative 2 is a positive 2. The reciprocal of 2 over 1 is 1 over 2. Now, the next sets of questions deal with the National Honor Society, who are selling green and white carnations. The florist charges them $32. That's their fee. And the club decides to sell 2 carnations for $1, 1 green, 1 white. That causes them to be 50 cents a piece. 50 cents can be written as the fraction 1/2 or 1/2, since it is half $1. Remember, slope we want to express as a ratio. So the cost being 50 cents is going to be written as 1/2. And it's 50 cents per carnation or $half per carnation. The next is the y-intercept. The y-intercept is along the y-axis, which in this case is the far left line that says earning in dollars. Our y-intercept is the initial charge that the florist gives the National Honor Society of $32. Since it's a charge, it's a negative 32, which means if they sold 0 flowers, they would still lose $32 for the charge. So when I go to write my equation, I need the slope and the y-intercept. Slope was 1/2, that's a $half per carnation, plus the negative 32. Because negative 32 is where my line began. Now, when the National Honor Society Club breaks even, I'm looking for when will my equation have a y of 0. 0 is the amount to break even, meaning you've recovered the $32 that you had to pay the florist for the flowers. So it means whenever y equals 0, I'm going to substitute and solve. I'm substituting 0 in for y. I'm going to use the equation that I've now written of y equals 1/2 x plus negative 32. And that equation is going to help me answer the next 3 questions. So, y equals 1/2 x plus negative 32. I need to set y equal to 0 and solve for x. In order to solve for x, I have to add 32 to both sides. Replacing y with 0, I add 32 to 0, and I end up with 32 now equals 1/2 x. Well, to get rid of the fraction 1/2, I can divide by 1/2 or multiply by the reciprocal. This goes back to an old unit when we were studying the solving of equations, especially those multi-step equations involving fractions. So I flipped 2/1 to cancel out the 1/2. On the other side, I'm going to multiply numerator to numerator, denominator to denominator. So 2 times 32 made 64, which means it'll take 64 carnations. X will have to be 64 in order to break even. That represents this point here on the graph between 50 and 75, where the line goes and passes through the x-axis. So I break even at 64 carnations. I'm going to use that same equation again to figure out how much I'd make in total profit if 225 carnations were sold. Again, carnations is represented, the number of carnations is represented by x. So I'm simply substituting in 225 for x. So half of 225 plus a negative 32. Half of 225 is 112.5. Plus a negative 32 is the same as subtracting 32. So just remember, you'll have a decimal left over. And that decimal will represent the 50 cents. So 0.5 represents 50 cents. So 112 take away 32 leaves me with $80.50. As you can see, I'm writing $80.50 with a decimal and a 0 as a placeholder. That's the profit if 225 carnations are sold. Not much money for that many flowers. The last question, again, we'll revisit the same equation. But this time it's asking how many carnations would the club have to sell if it wants to make $800 profit. The profit will go in for the Y value. And I'll have to solve for the X, because I don't know how many carnations to make $800. I can estimate if I look at the graph above. So if I had a graph that continued up above $200 earning, I could predict. But I'm going to use the equation and solve it to get the exact value. So again, solving it is a two-step equation. You add 32 to both sides. So now 832 equals 1/2 x. If I want to get rid of a fraction, I multiply by its reciprocal. So 2/1 gets multiplied to both sides. We could treat 832 as a fraction by putting it over 1. Just remember that 1/2 and 2/1 cancel out to leave me with just x. And 832 multiplies to get 1,664 all over 1, which makes 1,664 carnations. That's not a bad number of carnations, but you'd have to sell quite a few to make that $800 profit. Needless to say, I'm not going into the flower business.